you're on your best behavior.
All right, so here we go. We're going to subtract 9 from each side. So 4x is greater than 12. So it's going to be 2 steppers to 4 steppers in here. Next step would be divide by 4. So x is greater than 3. You might be asked, you could be asked to graph that on the skill test, or you could be asked to give an example of a number that's in the solution set. What would be a number in the solution set?
4.
4 would be one, yeah. Okay, we're not going to do all these down here. We're going to do just one of them. I think we'll do this one in the middle, so you can X out this guy, X out this guy. This one in the middle, you are going to have to flip the inequality. Also, notice the letters on the right. So I'm going to subtract 5 from each side. That's what I would do at least. So I have -9 is less than -3n. I do have some students who like to start by getting the letter on the left immediately. If you wanted to rewrite it as 5 minus 3n, make sure it's still opening in that direction, -4. And then you could go through the process. You get the same thing as I'm going to get here. So we're not going to do this one. I'm going to skip it. So divide each side by -3. And when I divide by -3, I should not have written that yet. What do I have to do when I divide by -3?
Flip it.
Yeah, so it's pointing to the left to start with, so now it's going to be pointing to the right. So I have 3 is greater than n. Now, if you're just solving the inequality, it's like an equation. You could just leave it like that. I've been asking you, or recommending, not asking you, but recommending that you put the letter on the left. The only reason for that was so that it would help you in graphing. When the letter is on the left, so bn is less than 3, I end up flipping the inequality back, right? It's still got to point towards the n. But when the n is on the left, then kind of follow that direction for my graphing. I have 3 right here. It works like an arrow. I'm going this direction. But if I'm not asking you to graph it, there's no real reason to switch the letter to put it on the left, okay? But you're welcome to. Any questions on that? This next one, we're just going to change the problem. You can't really see it on yours. So what we're going to do is just pretend you have a garden that you're going to fence in. Don't worry about your friend's garden, the adjacent part. Your garden, you have at most 42 feet of fence to work with. Right here, the width of your garden is going to be 12 feet. It's got to match your friend's here. You can't be going outside of that. So we have this little formula for perimeter. It's twice the length plus twice the width equals the perimeter. Now we're going to turn this into an inequality. It says you have at most 42 feet of fence. So if we have at most 42 feet of fence, we have to stay less than or equal to 42 when we go to build our fence here. And so our length, we're going to figure out what length we could have, or what lengths we could have. It could say plural. It's up to a certain amount. So we have twice the length plus twice the width of 12 has to stay below 42 feet. So I have 2L plus 24 is less than or equal to 42. So the 12, you can't see it on yours, okay? But the 12 feet came from right here. So that's in there. It just doesn't show up on yours. So I'm just starting this problem over again, okay? So we could say the W equals 12. We could, if you want, you could write it out here on yours. You can do that if you'd like. That would be a good idea. So subtract 24 from each side. So I have 2L is less than or equal to 18. Divide by 2. L is less than or equal to 9. So my length here, this is kind of out of proportion here, but my garden is only going to be up to 9 feet. So possible lengths of your garden is up to 9 feet. Because my perimeter has to stay under 42, and I've already used up 24 feet of the 42 with that width so that I match everybody else's garden here. Yeah, we're going to go ahead and do that one. You see how this is similar to the top? Like, it says you have no more than 48 feet. So you have 48 feet of trim. Trim would be perimeter, right? So I've got to stay below 48 feet. I know that the banner, I want it to be 18 feet long. There's going to be 2 of those. So 2 times 18 plus 2 times W has to stay less than or equal to 48. Why don't you go ahead and solve that? Figure out what the possible widths of the banner would be. So we get a width, the possible widths of the banner, it's got to be less than or equal to 6 feet. So 6 feet would be your max for each one. So 6 and 6 and 18 and 18 add up to 48. 6 is correct. All right. This next one here, guys, is going to be more than 2 steps. So we've got distribution going on here, combining like terms, inverse operations, a couple of them here. Let's wait to use that bathroom pass until after the notes are done, if you guys can wait. Or ask me first. No. Ask first. All right, so distribute here. We're on problem 3 right now. So problem 3. Problem 3. So we're going to distribute first. So we've got 3x plus 3 minus 4x greater than or equal to negative 5. That's the first step of 4. There'll be 4 steps on this one. What's the next one?
Combining like terms.
Yeah, take these 2 here and here. And 3 minus 4 is negative 1x. I'm going to write the 1 next to the x, just for the purpose of not losing that negative sign in front of the x, because that's going to be important in that last step. Subtract 3 from each side. So we have negative 1x is greater than or equal to negative 8. And then divide.
Should be 8, right?
It will end up, we flip the inequality, negative 8 divided by negative 1, x is less than or equal to positive 8 is correct. Yeah, you gotta make sure you flip the inequality when you divide by negative. Alright, try this one please. I'll just let you get a head start and then I'm going to follow up shortly after. So we got m is less than or equal to negative 3. Even though m is on the right, we'd read it from m's perspective. It's less than or equal to negative 3. So negative 4, negative 5, and so forth. So that's a 4-stepper. Okay.
Wait, to combine the like terms and you add them or
All right. Variables on both sides. You have different options here. What I've recommended, and it really pays off when you're doing inequalities, is if you can keep a positive number in front of the variable, you don't have to worry about flipping the inequality in the end. So I would subtract 3n from each side. Could you add 1 first? Yes. Could you subtract 6n over? Yes. I mean, there are lots of different options, but if we can keep that number in front of the letter positive, we don't have to flip the inequality's direction later on. So add 1 to each side here. 3n is greater than 9, and then divide by 3. So n is greater than 3. So you just run out the same sort of steps that you would do with an equation. So you do have options. You could do other things other than add 2b, but that's what I did, just to get a 5b out in front here. So as you go through, I didn't assign a lot of problems. It's a Monday as part of it, but there's like 1 of each type, 1 or 2 of each type. So until this last problem. Oh. Let's start over again here. Reset page. There we go. So these are inequalities of special solutions. When we say special, we're talking about no solution or in all reals. Okay. So let me show you kind of what this looks like with inequalities. It's very similar to equations. Basically, if you get an inequality that's true, that means it's all reals. If it's false, that means no solution. So let's see what happens as we go through our solving process here. This would be 10 minus 8a, and I have 10 minus 8a here. Already I'm seeing an identity taking shape here. There's an identity taking shape here, right? Except that it can't be an identity because we have an inequality symbol here. Let's see what happens. Let's add 8a to each side. The a's cancel here, cancel here. We have 10 is greater than or equal to 10. So you have to ask the question, is this true? Is this a true inequality? Because if it's true, anything I would have put in for a in the beginning would have worked. It wouldn't have mattered. So is this true? Is 10 greater than or equal to 10? It's not greater than itself, but it's equal to itself. So this is true, yes. It's true. That means what? What's the interpretation then? All real numbers. So the solution set is all real numbers. Okay, all real numbers. Let me show you what the no solution case looks like. So don't just write down no solution. You have to see what's going on here. 7m minus m is 6m plus 7. So I combined these two terms in that first step. Subtract 6m from each side. So I have negative 5 is greater than 7. So is this true? Is negative 5 bigger than 7? Well, did you combine the like terms first? That's it. You don't have to, but it's an easy place to mess up. Is if, for example, you subtract 6m from both of these, you're going to have an issue. So it's a good idea to get one letter and one number on each side first by combining the like terms so that you don't have multiple like terms there. Then you're adding and subtracting more than you needed to. So if you combine like terms, you will get 6m. When you subtract 6m from each side, it disappears, giving you this statement. Negative 5 is greater than 7.
Well, I did adding 5 first.
Uh-huh.
So it's 12 on that side.
Okay.
And then it was 0. 0 is greater than 12.
0 is greater. Okay, that would work. But is that a true statement? No, so you have the same conclusion as me, right? See, if I took, watch this, if I took and added the 5 over, I would have exactly what you have. 0 is greater than 12, which is still not true. So since it's false, we would say there is no solution. I'd like you to try these last two here. Now you try. You should find one of each of these cases. So see if you can figure out which is which. So yeah, it should have been no solution for the first one and all reals for the second one. 9 is not less than or equal to negative 1.
Wait,
And
why all real?
all reals because is 8 greater than or equal to 2?
I got 6 greater than or equal to 0.
Is 6 greater than or equal to 0?
False.
No, is 6 bigger than or equal to 0?
Oh, yeah.
Yes. So no matter what you do, right? No matter what letter this has in it, it's going to be true. So because this is always true, you're not trying to get them equal to each other. It says if this number on the left is greater than or equal to the number on the right, which it is, then all real numbers would work in this inequality.
What?
Yes.